We can also use similar concept to multiply monomial by a polynomial. So instead of multiplying single terms together, we are going to multiply a single term with a two terms binomial or more. And we are going to use the distributive property to do it. But before that, let's see how we can use algebra tiles to work with polynomial. I know some of you have no problem with this concept at all, but I'm going to tell you, you will see it on your provincial exam. Some of us totally have no problem working with polynomials. You can do everything without using algebra tiles, but they're going to make you learn that concept. So here is how you work with algebra tiles. If we are starting with a square that has xcm on all four sizes, if this is my algebra tiles, the area of this algebra tiles would simply be x times x, length times width, or simply x squared. This is what you would do when it comes to regular multiplication. Every algebra tiles that has xcm for its side length will give us x squared for its area. But what if we are to make it bigger? If I want to stretch this square horizontally by 1 cm, so I'm going to copy this square and then copy it. Let me actually draw it out again. It seems like I cannot be that lazy. So instead of having x and x for my algebra tiles, I need to make this square bigger. And that's why I'm using dollar line. I need to expand one side by 1 cm. So you are adding a 1 to it. So this is what is happening. Besides having x by x for your algebra tiles, you are adding 1 cm next to it. And this algebra tile will have the same length for one of the sides. Well, we know the area of the square is x squared. But what about the rectangle on the right hand side? Just x, 1 times x. That is the area for the rectangle there. Length times width equals its area. 1 times x would just be x squared. So adding the area together, we have x squared plus x for its area. But if you want to use the distributive property, seeing how we have x on one side and x plus 1 on the other side, multiplying the length by the width will now give us x squared plus 1x. So you will end up with the same area as you do it with algebra tiles. You can also expand your square on the other side. So not only we have the original square with x by x, Once again, I'm using dotted line for all these sizes. If we are adding 1 cm from part B and 2 cm on the other side, 1 cm, 2 cm, which each of them having the same length at the bottom, we are not quite getting a rectangle yet. When you want to expand the side length by 1 cm here and by 2 cm there, these algebra tiles are not enough to give us a rectangle. We need to fill in the space with 2 little squares, with 1 for its length and 1 for its width. So technically, I have one area of 1, an area of x squared, area of x, and x all together. They will give us the area of x squared plus 3x plus 2. But if you were to use the distributive property for its area, we have length times width we can expand it by doing your multiplication one at a time. We saw how we multiply a single term by a binomial. But when it comes to 2 terms, multiply by the second bracket, I'm going to do my multiplication one at a time, following the order here. Once I'm done with the multiplication between the x and the 2 terms here, I'm going to multiply the second term in the first bracket by the 2 terms there. So here, as I do it for the first step, x times x will give us x squared. And then we multiply the x by 2. Once you're done with the x, you can move on to the 1. Multiply the 1 by x, and finally multiply the 1 by 2. And now as you add the like terms together, we will end with this result. This method of expanding binomial with another binomial is what we call FOIL. What does it mean by FOIL? You multiply the first term of the 2 brackets at the beginning. Then you multiply the outside of the 2 brackets. So here, I multiply the outside of the 2 brackets. Then we will move on to the inside. We multiply the inside of the 2 brackets, 1 times x, that's the third term we saw. And finally, we multiply the last term of the 2 brackets. So every time when it comes to multiplying 2 binomials together, you can always use the acronym FOIL to expand your polynomial.